Right, here is my video guide for lesson 10.3.3. The purpose of it is to learn about combinations and how they differ from permutations. Yesterday we learned that permutations was a specific arrangement where you cannot have numbers repeat, and the order in which those numbers or those choices are made are important. What you'll see here today with combinations is we still can't have numbers repeat, but this is the case where order doesn't matter. And so we had a problem like this yesterday, and we're going to take it a step further here today. And I think I can do most of the explanation of really what a combination is here in this first problem 134. So I'm going to read the intro. In the previous lesson, you learned a method for counting arrangements, including permutations. In this lesson, you will consider questions such as how many 5-card poker hands are possible, how many spirit committees can be selected from a junior class, or your chances of winning the lottery. So the one that we had yesterday was actually that spirit committee. And the way that they prefaced a combination problem was that there was a group of 5 people and you had to choose 3 of them to go in a spirit committee, but there was no roles to that spirit committee. So there wasn't a president, a vice president, and a secretary. And since there was no role, the order in which you chose them didn't matter. And so we'll see that here in this first problem. Okay. Again, if you go to the ebook, you could click on this word combinations and it'll give you the definition. We'll see most of that definition come out throughout the lesson here today. So the first problem here, an important one, and we'll get right into it. So 5 members of the Spirit Club have volunteered for the club governing board. These members are Al, Barbara, Carl, Dale, and Ernie. The club members will select 3 of the 5, as board members for the next year. One way to do this would be to elect a governing committee of 3 in which all members would have the same title. A second way would be to select a president, vice president, and a secretary. And right there is going to be the thing that separates us from a permutation and a combination. So in that second way here, it says they select a president, a vice president, and a secretary. There the order matters, because if you select Al to be the president, there could be a different order where Al is still in it, but Al is the vice president. There could be another order where Al is still in it and Al is the secretary. And because of this, this leads to more choices, more arrangements, because of the fact that they could play these different roles. Whereas in the first option, where everybody has the same title, if Al gets selected into that committee, there's only so many times he could get selected into that committee. Because he could get selected, we'll see it as we keep going, but he can get selected a certain amount of times, but after a while there isn't as many combinations because there just isn't as many options for him to go. And we'll see that as we work through it here. So it says, first for part A, how many different lineups of officers are possible? This means a president, vice president, and a secretary are chosen. Thus Al is president, Barbara is vice president. So they're really just saying, let's do the second way first, where we have roles and where the order matters. And so for part A, it's going to be a permutation problem. It's going to be a permutation problem because order matters. We have 3 decisions to be made. We have a president, vice president, and secretary. So I'm going to do my decision chart with first, second, and third. Now, on the first choice, you have 5 people because you have all of the contestants, Al, Barbara, Carl, Dale, and Ernie. And so you have 5. After somebody gets chosen, let's say as president, you only have 4 choices then. Let's say somebody gets chosen for then vice president. At the end, you only have 3 choices. And there goes our decision chart looking like a permutation problem we saw yesterday. We'll multiply down our decision chart. You have 5 times 4, which is 20. 5 times 4 times 3. So 5 times 4 is 20. 20 times 3 would give me 60. So there's 60 different ways you could arrange a president, a vice president, and a secretary given these 5 candidates. Okay? So that's permutation because order matters. Now B here is going to get into this idea of combination. So what it says is how many different 3-member committees are possible. In this case, this is just 3-member committees, no roles. There is no president, vice president, so order doesn't matter anymore. You can just get selected to the committee or you don't get selected to the committee. So in this case, it is good to make a list of all the possibilities, and we're going to call those our combinations. And so this gets a little bit long, but we're not going to do a list of 60, which is nice because combinations are smaller number of arrangements. And really what I'm going to do here, I'm going to say Al, I'm going to call Al A, Al is A, Barbara is B, Carl is C, Dale is D, Ernie is E. Okay, and I'm going to see all the different ways I can arrange those. So I'm going to arrange A, B, C, D, and E, and I got to arrange those into groups of 3. And I got to try to get all of them here. And so the first one I'm going to do is the combination A. I'm going to kind of separate this just because that's my list that I'm going to base it off of. So my first one is going to be A, B, C. My second one is A, B, D, A, B, E. I'm going to extend my page a little bit here. Oops. So I'm at A, B, E. I have then A, C, D. I have A, C, E. A, D, E. B, C, D. B, D. E. B, C, E, and C, D, E. Okay, and I believe that's my entire list here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different combinations. Now, I just listed these out. I probably could have paused it and did a little editing here. I'm sorry that I didn't, but I wanted to list them all out, and then I wanted to talk about why these are the most combinations I can do here. And it's because we cannot redo certain ones. So you can see that my first one was ABC. All right. I don't have in this list CBA. I don't have that in my list because that's just your first one, the first combination rearranged. And since order doesn't matter, that's the same thing as this. Since order doesn't matter, CBA is the same thing as ABC because either way, the same people are on the committee. You know what I mean? We have Al, I forget the people's names here. Al, Barbara, and Carl. Yeah, Al, Barbara, and Carl. In this case, you have Carl, Barbara, and Al. So the same people are on the committee, and that's why we do these combinations, because we don't want to talk about that being an option, because it's not an option because it's already covered right here. And so another case could be, if you wanted to see another one, would be like EDB. EDB is the same thing as this one right here, and that's why we don't want to include it, because we already accounted for it right there. And really my trick to when I was doing this problem, and I know I'm taking a lot of time here, but the second video will go quicker. The trick I do here is I just go through it. I did ABC. So I did ABC, and then I did ABD, and then I did ABE. Now that's the ABs are kind of accounted for, so then I switched it to ACD, and then ACE, and then your ACs are accounted for. And then I switched it to ADE. There was only one of those, and then I moved to B, and then after I complete the B's, I move to C. And it's just a kind of a nice way to do a systematic list. These take a little bit of practice. I know when I was doing this problem the first time around, it took me a while and I kept missing a couple of them. So be sure to ask if you're trying a problem like this and you don't know if you have them all or not. Be sure to ask. All right, we're going to keep moving here and move on to C and just kind of look at the different possibilities. Again, we're going to look at a permutation part and a combination part. So what it says is Felicia decides that she wants to volunteer as well. And so instead of having A, B, C, D, and E, we are now going to include an F. Because Felicia is now going to put herself out there and try to be a volunteer for the Spirit Committee. And so now it's asking how many different possibilities for officers is there now? Or really it's saying if we're going to do a president, a vice president, and a secretary, how many different permutations or arrangements are there now? And so this is part C, number 1 of part C. And again, if we're talking about having a president, a vice president, and a secretary, we have decisions and order matters. And so we have a first decision for president, a second for vice president, and a third for secretary. And now that Felicia is in the race, we have A, B, C, D, E, and F, which is 6 people, right? 1, 2, 3, 4, 5, 6, including Felicia. And so when you're talking about the first choice down here, you have 6 options for who could be president. After the president's selected, you have 5 options. After the vice president's selected, you have 4 options. All right, and so that becomes our kind of our classic permutation problem. We multiply down our decision chart there, and 6 times 5 times 4. 6 times 5 is 30. 30 times 4 is 120. And so we have 120 options if, or really 120 different arrangements if you have the kind of permutation or the president, vice president, secretary options. There's 120 different options there. So then it's going to tell us now, let's make a list of the different kind of governing committees, or we're going to make a list of all the different combinations, meaning that order doesn't matter anymore. All right, and this time I am going to do some fancy editing, and I'm going to make my list. I'll start it, but then I'm going to pause it and do some editing to finish the list because it's a little bit longer than the last one. But again, my options here for part 2, the options that I have to choose combinations from are A, B, C, D, E, and F, and I'm going to make groups of 3 out of these letters. And so my first one is going to be A, B, C, A, B, C. So Al, Barbara, I forget names, Caleb, I don't know. And then my next one's going to be A, B, D. My next one after that is going to be A, B. I did A, B, C. I did A, B, C. I did A, B, D. So A, B, E. And then my next one's going to be A, B, F. And then after A, B, F, I've done all the A, B's, so I'm going to start doing A, C. So then A, C, D. And now I'm going to go do my editing magic. So I'm going to pause. I'm going to finish the list, and I'm going to come back, and we're going to look at it and evaluate it. This is my completed list of combinations. There should be 20 of them. I'll try to get them all on the page here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 different combinations here. And you can see I kind of did like my pattern was in the beginning. I did ABC, then ABD, then ABD, then ABE, then ABF. So that did all my ABs. And then I moved on to the ACs, and I did ACD, ACE, ACF. That covered all the ACs. So then I moved to AD, and then I had one AE. And then once all my A's were finished, then I moved to B's. And again, I'm not repeating any of them. So working that kind of pattern, that kind of strategy helps me not repeat. Because if I'm just kind of choosing them, eventually, like I'm looking at it and I'm just picking random ones, I would do something like I would choose FBA, and FBA was already covered by this one. And so it's nice to kind of work in that order of like, I want to do all my ABs, then my ACs, then my AEs, and I work through it. And then after I see that I haven't done any more A's, then I go to B's, and I do BCs, BDs, BEs, and then I realize that I've worked through all the B's, so then I go to the C's. And it's a good way to kind of get them so that you don't end up repeating. And honestly, as of right now, I don't have the best strategy other than that. And I will show kind of me doing that again because we have one more combination list to do here. But what we have here, I should write it down, is we had 20 combinations. So we had 120 permutations, but only 20 combinations. All right. Again, and that's really what happens when order doesn't matter. Okay. So we're going to move on here. We have one more to do, D. Since there are more volunteers, the Spirit Club has decided to appoint another committee member, meaning that there is going to be a treasurer added. And so there's going to be a president, a vice president, a secretary, and a treasurer, which is going to change our permutation. And the other possibility is just having a 4th committee member, which means it's going to change our combination. So when we pick this up in part 2, you're going to see a different kind of permutation and a different type of combination.